Hello everyone, my name is Shiveish Chetty and I am here to explain my project about online payment for detection using ML. I am from IIT Kanpur and so I have directly made the code in the Kaggle because of the data set. The data set was present at Kaggle, so it would be easier for me to directly upload the data set and take the information from it. So let's take a look at the code. The very first cell represent all the necessary libraries which I have imported like NumPy, Panda, Seaborn, Matplotlib, and sklearns, and there are many things like test chain split, standard scalars, logistic regression, decision tree classifiers, Gaussian NB, etc. And I have also imported the warnings. In the next cell, I have defined how to load data, means how to load any of the data from the data set and which will be used in the later on code. Next cell represent how to explore data. Basically, it's just to see what are the dimensions, summary, and the main data types which are included in the data set. And the next cell describes means how we are handling the missing data. So this first line df is null dot value dot any. It basically just takes or makes a list of all the datas which have null value or zero value and just drops it. The next cell is nothing but just visualizing the outliers. It uses a very basic method which is to plot a box plot, and after that using means all the data which are above that certain 75% or 25 below 25% range, those are considered as outliers and can be removed later on. Mm, And the next cell is means kind of crucial. It is to plot category count. So it just shows how many categories are there in a given column or something. As we can see, it's data frame comma column. So it just shows the data categories of the column. The next one is also means it is one of the main parts of the code, which is encoding or mapping the columns with something like the types of payment methods like payment, checkout, cash out, cash in, and we just map it with 0, 1, 2, 3, etc. The next code is splitting data features. Um, so it is for its like means we just take out that features column and create a separate data set for it so that it will be easier to calculate or do some operations on it. The next is scalar data. It is we just means train and test data. We just fit the data firstly and then use the standard scale operation on it. The next will represent plot scores. As you will see on the later on code that the result will give many graphs. So all those graphs will be coming from here. This plt.py, that plt.py code gives us a pie graph which you will see on the later code on the results part and title axis. And this show it just shows the graph after it's completely made. The next cell is evaluating the model. We just defined how to evaluate the model. So we described all the necessary terms like prediction, accuracy, precision, recall, F1, and accuracy of ROC. And these all are actually the features and the functions from the libraries which we imported, so it can be calculated pretty easily. And we just print them. Confusion matrix is also means it's also a crucial part of the code. And at the end, we just plot the graphs of it using all these names. So this all comes under this evaluate model function, which we define. And here comes the main part of the code. We just define a file path and then we just load that data. Then we explore that data. Then we visualize the outliers and all these things are which I mentioned above. In the next, we just encode the data. It's just like I said, cash out is a map to 0, payment to 1, cash into 2, transfer to 3, and debit to 4. And all that data which are zeros are dropped out or removed. With then data splitting, we just split the data. So which one should be trained and which one should be used for testing. So the test size is zero point 0.3 as given here, and the random state is also defined so as to maintain that spontaneity, etc. And we just train and scale the data. And after that, it's like the models. So logistic regression, decision tree classifier, these functions are used. And at the end, we just create a to list and we put it in the for loop. First, we made to fit all that data so that there is no dimensionality problems, etc. And we just evaluate it. Uh, and after evaluation and completely running through that code, we will see something like this. So these were all the data set tests we did for evaluating, means for checking what is the data. And after that, these are the evaluations. Outlier visualization is this graph. And after that, this graph is the confusion matrix and that pie chart graph I said you about the before. And these are for all those three things which I shown here. Logistic regression, decision tree, and analysis. So as you can see, the accuracy is pretty high, 99.87, 99.95, 99.61 for logistic regression, decision tree, and web issues respectively. And after we have trained the model completely, we just now need to take the inputs from the user so as we can to predict that it is fraudulent or not fraudulent. So for that, we have defined another function which is to get the input and predict. It include variables like model, scalar, and featured column, which will be used. The featured column is essentially we used for taking in the informations like the number of steps involved, which type of payment, and original bank balance and current bank balance, etc. Mm, and what can I say? This code for features in features column. This is what I just described. And after that, we just convert the input which we have taken from the user into the data frame. So we are using the pandas for it, pt.data frame. And after that, if type in features, so it's ultimately that mapping only. And scaling, then we finally we predict. So is fraud predict model, we use the predict function, and if the value of is fraud predict, which we used, which we calculated using the predict function is 1, then it is fraudulent, otherwise it's not fraudulent. And so we just use if name equal to main. This is just to ensure that this main is directly ran in the model, otherwise, and not from anywhere else, etc. And after scaling everything and fitting, we just train models and print out the results. And fetch user, this is the function we defined, and by using it, we can just ultimately take the input. So as you can see, I have already done one for the non-fraudulent one. Here, mm, we just entered the value for strips, which is 100, and type which is the type, then the type is payment, and enter the value of amount was 10,000. Old balance was 20, the new balance was 1,000, and as you can see it fits completely, so it's non-fraudulent. Means I have to run all these cells again. So it will take some time as it has to do all that training part, etc. So yeah, the code is running. So it just took out the data sets, means the data frame, and now it will show all those graphs. So this is the outlier visualization graph. So all these dots represent those outliers which are very different from the main data. And this is for logistic regression. The next one should be for decision. So as you can see, now that the training is complete, again, so now it's time to enter the values. So let's say the step number of steps is 100. The type of method is payment. The value is something like 9899, and the old balance is 90000. As you can see, it should be fraud, and I run that, and it showed it's fraudulent. That's all. So we can say that our code is running correctly. Thank you.